Welcome to Keep FM. Can you tell me a little bit about who you are, what's your role, and where you work?
Hi, and thanks for having me on the show. My name is Aaron Wright. I am a software engineer at Plumi. My focus at Plumi is on Kubernetes integration. Plumi is a pretty vast product, actually, that integrates with lots of different technologies and services, and my focus is on making the best possible experience for Kubernetes users. I actually came to Pulumi a year ago from a cloud startup called Stream Native, which provides Apache Pulsar as a service across different clouds. And we were struggling with how to deploy those workloads across so many different clouds. Kubernetes was sort of the foundation there because Kubernetes is kind of this reasonably portable foundation for building cloud services. And so we felt that steeping our or basing our service on Kubernetes was a good way to do that. And so we would use EKS or GKE or AKS as necessary to deliver that workload. And Pulumi was always a part of that. And so when I was looking out for another opportunity, my first stop was at Pulumi. And it's been a great time since then.
Fantastic. Now, tell me about three emerging Kubernetes tools that you're keeping an eye on.
I am pretty focused on Pulumi and how Pulumi works great for Kubernetes workloads. And that means working with Kubernetes tools. Top of mind is probably always Helm, because Helm is, the de facto package manager for Kubernetes. And so watching what's going on with Helm, anticipating Helm v4 is really interesting. And that's so that, Pulumi, maintains this ability to deploy Helm charts, well. So Helm is top of mind always. Second is Kubernetes itself. Kubernetes continues to evolve and adding features that round out the type of applications you can actually run in a Kubernetes environment. So, for example, just looking at what has come recently that I'm personally interested in is support for image volumes, which is this ability to actually attach secondary Docker images to a pod to use them as data sources or as for content. That's really exciting to me. And then this ongoing thing with what they call server-side apply, which is a strategy for supporting multi-party authoring of objects. Kubernetes is actually a really sophisticated API in how it makes it possible for different parties to be working together or collaborating on the objects that sort of constitute a workload. For example, you might have a tool like Pulumi managing the deployment of a particular set of pods, but letting an autoscaler handle the replicas. So it's handling the scaling. And that means that there's multiple tools actually editing the fields of a deployment. And making all of those tools work well together is what server-side apply seeks to do, but it's a lot harder to integrate into tools maybe than meets the eye. And so that's another area where there's sort of an ongoing investment. And then a third tool or whatnot that I'm interested in is OCI. We've seen OCI registries, become a great source for whether Docker images, Helm charts, and whatnot. And so being able to support authentication and things like that is an ongoing thing.
Now, some of the questions we're going to follow, the questions we're going to look at next are ones that have come up as a result of different podcasts that we've done and different topics that our guests have mentioned. So when it comes to the topic of automation and resource management, one of our guests, Alexander, expressed that having an automated mechanism is better than enforcing processes. What automation tools or approaches do you recommend for managing Kubernetes resources?
I would definitely recommend Pulumi. Pulumi, naturally, Pulumi IAC is all about automation, right? In fact, it's about automating the deployment of workloads, using your preferred programming language. And how it works is using your language of choice, which might be TypeScript or Python. You are sort of declaring the resources that you need, sort of a declarative approach. And then Pulumi maintains state to be able to figure out, what actually needs to be done so that what has actually been deployed to the cloud is in alignment with your goals or your stated desired configuration. And so I think automation is very practical to do if you have a tool that lets you kind of work in that way, sort of a declarative way. And Plumi, I think, is best in class in that. To speak to your point about processes, though, some of that can have to do with, for example, like policy enforcement. And that's another area where Plumi really shines, because Plumi has this whole policy as code subsystem that we call CrossGuard. And that lets you set up guardrails to sort of enforce, compliance, so that developers, can provision their own infrastructure within an organization while sticking to best practices and security compliance.
In terms of GitOps and platform engineering, another one of our guests, Hans, argues that GitOps is an excellent building block for building platforms with great developer experience. He mentioned the ability to merge, review, and discuss code changes in PRs, and the additional benefit of not granting permissions. Should all platforms use GitOps? And what's your experience?
When I think about deploying software to the cloud, I think of there being many environments I'm going to deploy that software to, and I want consistency across that. So I'm obviously going to use automation there, and if I'm using a tool like Plumi, I can use ordinary code to really articulate what I need. How Plumi works with GitOps happens in at least two ways, sort of at two levels there. One is the program itself. So the source code of your program that might say, I need a pod, I need a service account, I need an IAM role. These are all parts of my program. All of that is under version control, and we're using pull requests and whatnot to review, the infrastructure code before it's deployed. We also get to review the configuration. So you'll see there's a configuration change to the staging environment or a configuration change planned for the production environment. And so both the code and the configuration is all in Git, and you get all of that beautiful workflow from systems like GitHub. If you're using that in combination with Plumi Cloud, it's even better because, and this is something that really attracted me to Plumi when I was outside the company as a customer, is the really deep integration with GitHub that is there, and other providers as well, so that when you open those PRs, Plumi will come in and annotate the PR with, here are the stack resources that are going to be changed. It actually embeds previews into the PRs and whatnot. So you get this really visual experience about, you're working with code, but you get this really sort of lit up experience at like what is going to change if you merge this PR. The second level, if I could just say a few more words, the first level is the program itself. But there's a higher level of automation too in automating just the stacks themselves. What a stack is in Plumi parlance is an instance of a Plumi program that's been run in a particular environment. So my staging deployment, my production deployment, those would constitute two stacks that were based on the same program. The need to deploy those stacks, though, like I want to deploy the staging environment in a certain way, well, that's something that you can use some of the higher level technologies that we have around that. We have got, and I want to talk to you about a brand new Kubernetes operator that has been developed to be able to do Plumi deployments using your Kubernetes cluster. So Plumi is a tool. Where you run that tool to effect these deployments is the question. And we have this brand new operator so that you can run Plumi inside your Kubernetes cluster. And so it can act as sort of that control system for going out and doing those deployments, maybe to other clusters or maybe to the same cluster. And all of that operator experience is also GitHub's centric. So for example, with the Kubernetes operator that we provide, it can be told to monitor a Git repository that contains Plumi source code. And whenever that source code changes, it will kick off an update to the stack, and deploy those changes into your cloud. So Plumi is very much built for GitOps. And you can combine those things with other Kubernetes technologies like Flux, like Argo CD, which can then be used kind of at that top level to drive, top to bottom of maybe Argo might say, oh, we want to get that Plumie stack deployed into staging. So it'll create a stack object. And then that stack object is consumed by our operator, and that will run Plumie. Plumie will then figure out what resources need to be created or updated. So it's kind of all turtles all the way, and a totally declarative system is the end result.
Now, you did mention Helm earlier, and one of our guests, Jacko, said that he disliked Helm's approach to templating, mentioning difficulties with multi-line strings and loss of strict schema enforcement, but he did acknowledge the usefulness of Helm packages. Do you see more tools and companies tackling the Helm package manager with new and innovative solutions? Are you happy with the status quo? How should we install third-party packages into Kubernetes?
I mean, it's a great question. And I have to tell you, over the almost 10 years I've been working in the Kubernetes space, I have tried every tool that I think has existed at one point or another. And I just found Pulumi to be like the general solution that I was looking for. But Helm is actually still very much a part of that. So let me just say, the chart ecosystem is vast. And often those charts are authored by the component authors themselves, or at least we can think of them as semi-official charts in many cases. And so they tend to work well. They tend to, track the underlying component and changes that might happen in that component. So it's good to use those charts. And I would not hesitate to recommend using a Helm chart where it's available, especially if it's an official one. But Helm is insufficient in the real world. Let me give you a really easy example. Everybody needs to install Cert Manager in their Kubernetes clusters, because Cert Manager is just this component that provisions TLS certificates from like Let's Encrypt. It's a great component. Everybody loves it. How do you install Cert Manager? Well, the Helm chart would be the right start. And a Pulumi program can very easily install a Helm chart for you. We have a Helm resource, as it's called, that will install the chart. But installing Cert Manager, it's not just about applying the chart. You actually also need some cloud resources. For example, you need an IAM role. And if you're, for example, installing to EKS, you will create an IAM role for Cert Manager. You will give it permissions to write to Route 53. And then you'll use IRSA to link that IAM role to the Kubernetes service account for Cert Manager, so that when Cert Manager is going to provision a certificate, it is able to make Route 53 DNS records, which is a part of the protocol that powers Let's Encrypt to go and provision a certificate for you. So deploying a given workload into Kubernetes, they're often not pure Kubernetes. They often come with a combination of cloud resources and Kubernetes resources, like that IAM role and those bindings and stuff like that. That's why Pulumi is so helpful, because it's able to reason about that broader ecosystem of resources, and in that compact program written in your favorite language like TypeScript, you can write components that sort of encapsulate this stuff at large. Like, here's that Cert Manager component. It consists of an IAM role. Take the IAM role's ARN and put it into one of the Helm values and deploy that Cert Manager chart, and boom, we have a working Cert Manager end to end. So do I love Helm? Yes. Am I excited about Helm v4 when it comes and what it contains? I'm sure I will be. Will I recommend users continue to use the vast ecosystem of charts? Absolutely. But do I recommend they just use Helm on the command line, or even something like Argo? No, I would recommend people consider using a tool like Pulumi in the middle there, so that they can actually build that whole resource graph encompassing both those Kubernetes and those cloud objects, and in a very nice way to boot.
Kubernetes turned 10 this year. What do you expect in the next 10 years to come?
I don't have a lot of insight into that. It's probably entering a stage of maturity. I think that in the last 5 years, it became readily able to run stateful workloads. I think the move towards serverless is important. And so being more elastic with my environments, being able to scale down to zero, being able to get the power of the stateful workloads in Kubernetes plus the stateless scalability is a really exciting direction in my mind. And then multi-cluster or cluster federation, I think, is really important. This is where, for example, in Google Cloud, we see like fleets of Kubernetes clusters that are working together, because Kubernetes clusters are regional objects. And so when you go beyond that into a more of a global scale to deliver a global service, you have to stitch those things together. And so I think that's another really exciting area of growth for Kubernetes is multi-cluster.
And what about you, Aaron? What's next for you?
Thanks for asking. I have been focused on delivering this new version of the Kubernetes operator, and we just made our beta, a public beta, available for people to try and give feedback. And over the next few weeks, we will be bringing that to a 2.0 GA release. So what I'm focused on right now is really listening to customers. I have to tell you, I was just so pleased that I had this opportunity at Pulumi to do a major architectural revamp of the operator, which is a technology we had developed a few years ago. But this new design that we have is more scalable and more isolated than ever before. Now, our Kubernetes operator actually runs these Pulumi commands inside separate pods. They're properly isolated with service accounts. So it's really ready for production use cases involving high scale clusters and multi-tenancy. So getting that into the hands of our users, we have already seen it is solving a lot of problems, and people have been waiting for this for a long time. So now it's time for us also to listen again and see what is those next moves we want to make. To just give you a couple of examples, we want to integrate better with Pulumi Cloud. So for example, Pulumi Cloud, which is one of the ways you can store the state of a Pulumi program is in Pulumi Cloud. Pulumi Cloud supports OIDC login now. So you can use the security tokens that Kubernetes clusters automatically generate for pods can be used as an identity when reaching out to a service like Pulumi Cloud. So being able to use our operator and deploy Pulumi programs without any need to configure credentials or tokens and just get a great out-of-box experience, that's another area we're really excited to do, because now we have that support on the cloud side. There's lots of things on our roadmap now that we have this new architecture in place. So that what's next for me is really doubling down on this operator investment and doing right by our customers.
How can people get in touch with you?
Thanks for asking. You can catch me in a few different ways. My email address is aaron@pulumi.com, and I'm happy to take emails. But you can also catch me on the Pulumi community Slack channel, our workspace. There's a Kubernetes channel there. So if anyone wants to chit chat about how Pulumi and Kubernetes work together, reach out to us on the Pulumi community Slack, and we'll be happy to talk your ear off.
Great. Thanks a lot, Aaron. We'll speak soon. Cheers.
My pleasure.